Dear friends, welcome back. In this video, the machine I'm going to do is Harry Potter Fawkes on the Vulnhub. The link will be added into the description section below so that you can download and play the machine if you want. This machine is also related to the buffer overflow attack. So this will take me a bit long time to finish. And I will, as usual, I will demonstrate the entire process step by step. So if you want to learn how to discover the buffer overflow attack vulnerability, and also to be more important, how to exploit such a buffer overflow vulnerability. So there will be a lot to take. Enough talk, let's just get started. We can switch into the Linux VM. First of all, we need to discover the IP address of the target. As always, I will use the net discover. As you can see over here, the IP address of a target could be discovered or identified as 120. Then we need to do the port and surface scanning with a map. To save time of this video, I've already done that earlier. So for now, we just get out the result of the map scanning. As you can see over here, I used the options like scene scan, the version scan, the default script scan, followed by the -P- to do the full range port scan. The last option for all is ON to output the result into this file. The IP address, as you can see over here, has been changed a bit from when I did the machine the first time. As you can see over here, the target has several open port numbers. For example, the first one is 21, running FTP surface and also the version information. From the default script scanning with the FTP surface, we can tell that the target allows anonymous FTP login. Later, we can use the manual to enumerate this FTP surface. The second one is 22, running SSH surface and also the version information. I don't think we can find any vulnerability with relation to this specific version of OpenSSH. The next one is 80, which is running HTTP surface and also the version information, Apache 2. The next one is 2222, which is running SSH surface as well. And although its version is a bit different, of course, similarly, we cannot find any vulnerability for this specific version of OpenSSH. The last one, a very high port number, 9898, and the Nmap cannot get the exact surface information and also the version information. However, from its collection to the target at this port number, we can get some information like welcome, blah, blah, blah. Of course, later we can use netcat to make manual enumeration or make manual collection. So what should we start off? Just I mentioned in the other videos, if you have already followed my channel, if the target has surface with relation to file sharing surface, for example, like FTP surface, in this case, the Samba surface. So I think we need to enumerate FTP surface first, okay? For example, we can use such as a point to see whether there is any vulnerability for this specific version of VS FTPD. However, no results. So next we can, we can log in or to connect to the target via FTP. And we can use anonymous as username and no password. And we can list out there is one file which should be downloaded obviously, right? We can get it down and we can exit from the FTP session. And the next, I think we need to check the file type of this file. As you can see over here, this is the executable or binary. And to run it, we can, we can make it executable, and then we can run this binary. However, nothing returned. So maybe, because this also we do not need to specify or the option, or we need to input anything. So I think the another possibility is that some specific port number has been opened by this application or this binary. Okay, later we can check it. But before we do such a check, I'd like to continue our immersion with other surface, HTTP surface, and we can, as I stated in the other video, following the standard methodology is very important. And we can put the IP address of the target into the address bar of the browser. Press enter. We got the page back. If you want, you can download the picture or image to the Kali Linux to make analysis to see whether there is any information like a hidden message inside the picture or some metadata. But I'd like to tell you, nothing like that we can find from this picture. To save time, I will not go through this process because I have already demonstrated such techniques for many times. If you want me to do that, please let me know in the comment below. And however, we need to check the source code of this page. Nothing else we can get. And next we can check whether this site has robots file. Not found. So next we can use Linkto to do the local, not the web application immersion. Of course, to save time, I don't think we can find anything useful from the Linkto. Next, we can use the GoBuster to do the directory immersion. Wordless, GoBuster, the directory, and extension option. Press enter. Of course, again, we cannot find any open or available directories or files except this default page. To save time, I will not wait anymore. So I think now we need to go back to see what's going on with that binary. Okay, the server Hogwarts, and let's run it again. And we can open up a new tab. Because so far, this should be the only possible vector for us to penetrate into the machine. And we can use SS to display active port number. As you can see here, this port number is open. This should be opened by the binary. What you can see over here, this one. So next, I think we can use netcat to do some testing. Also, this port number is exactly matches the port number on the target from the map. From the map, maybe I can show you. From the map scanning, we know that the target has this open port number, and this port number is exactly the same as this one when we execute this binary, right? So this should be, of course, before we try to make a testing or exploitation against the target, it will be better we make testing against the local binaries, okay? Because this would be safer. And how to test? We can use the netcat and connect to. And I think now we jump into the first step of the buffer overflow attack, which would be the spiking. So we can put some like AAA. We got the response, and we can put more data. For example, we can put many A's. Press enter. We got the same error, not error, the output. As you can see, we are forced to quit from the collection. And also, as you can see over here, we got the error segmentation fault. So it means that, of course, sorry, I forgot to do this one. We need to disable this, the address, the memory address space randomization. If not, we can make, the address should be random, not static. So this would be stack for us to write shell code. Okay, so very important. We need to disable this option. I've already disabled earlier. So now what I can do. So from this error, coming back from the application or software or binary, whatever you call it, this binary is vulnerable to the buffer overflow attack, possibly. So next we need to do some, we need to do some fuzzing. And how to fuzzing? Maybe we can use, through fuzzing step, we can get the possible location where the program or application breaks. Okay, so maybe we can use the PyCharm to write such code. Let's launch our PyCharm editor or IDE rather. I can make it bigger. So we can create the Python file, exploit, and we need to import some modules like sockets, which allow us to connect to the binary or application. Import time, import scenes. Sorry, not this one. And we can create the socket object. Socket, the IPv4 family, sock string, and then we need to connect to the local machine, and the port number is 90 and 98. And we can define the starting point to make a loop. That would be 10. And of course, as you can see, when we connect, we will get the response from the application. So let me, and also, of course, next we need to use the debugger GDB. Maybe not, do not need, we just run it. And we can while true. And we can use the, of course, we need to receive the data. Receive. And we can use try and except to capture any exception, right? We can, if there is any exception, we can print out the segmentation fault happened. And also I want to print out the current I variable, and then we can exit from the program. So next we can, the payload should be the capital A. We always use the capital A to test. Multiply the I, and then we can send. Of course, because I'm using Python 3, before we can send this data, we need to encode. And the payload encode UTF-8. And there we can receive the response. And then we can time sleep. For example, 1 second. And I, we add I by 10. Okay, so now we can save, and let's test this Python code exploit. So I think we have already got the possible location where the binary or application breaks. Next, we need to, so far we have already completed the second step. Now we go to the next step, which would be finding offset. So, offset is the location of the EIP. So after offset, this would be the EIP. EIP means the extended instruction pointer. EIP is the most important factor for the buffer overflow attack. We need to, for example, we need to overwrite this EIP. For example, we can point to the reversal code. Of course, we need to find the address of the jump ESP. The GSP, the jump ESP, right after the returned address. Okay? And we can use to wrapper to find it. So afterwards, you can see how I can do it in practice. Okay? So how to do? Now, I think another very important tool, GDB debugger plays important role. And we can launch the GDB and we can run. And as you can see, now we need to do, of course, next we need to, if we use the A and B, we cannot get the exact offset or location where the program breaks or the location of the EIP. So how to do? We can use the two. These belong to the Metasploit framework. And the tools exploit pattern create, and the length 200 is enough because the possible location is around 130. So we can press enter. As you can see, we can get this string, we can copy, and then we can connect to the binary or application again. We can paste in here. Press enter. And now we can display the address. So EIP. And now we need to, we need to get the, this should be the address. However, I need to get it offset. And now we can use another tool. Maybe I can disconnect. We can use the share midpoint tools, exploit pattern offset, and we want to search this one. As you can see, the exact match at offset 112. So it means that from 113, I mean like this one. So this should be our buffer, and followed by the EIP address, for example, the 4 bytes, and then for example, like ESP. So I think next we need to overwrite this to see whether we can overwrite this EIP. So how to test? We can, maybe we can open up another tab and zoom in. So we can use the Python tool. We can print the uppercase A, and offset is 112, 4 bytes, and then we can get this data, and we can connect to the binary. Oh, sorry. I think we need to rerun this binary. And then we can paste in here. As you can see here, we can print out, display the register. The EIP is filled by this one. Actually, this is not, of course, this should be the memory address of the next instruction. However, if you display this address, it will give you the error. Cannot access memory at this one, because this is just, this is the hex of the capital B. It means that B, the 4 Bs, has been filled or overwrite into the EIP. It means that we successfully overwrite or overflow into the EIP. Next, we need to get the address of or location of the jump ESP, which is right after the EIP. And we need to point the EIP into this address. Okay, so let me show you. And we can use the wrapper. And we want to search GMP ESP. We can press enter. As you can see, we got this address. This address should be put into the EIP. You know what I mean? This should be put into here. And then followed by the shell code. For example, like a reverse shell code. Of course, when we use this one to exploit, we need to reverse this address. Okay, so let me write the Python code to exploit. Okay, so we can create another exploit. And we can copy. And also we can copy this one. So next we can payload is oh, sorry, my mistake. Since we have already found the the address of the jump ESP. But before we can construct the shell code or payload, we need to find the bad characters, because if the bad characters is in the shell code, and these such bad characters will affect the execution of the shell code. So before we need to identify such bad characters. So how to do? We can, of course, I've already got it down from the GitHub, and we can go inside this one, and then we can run this shell script to generate these bad characters. And if we put these bad characters into the payload, and if some specific character is out of place or is not there, and such character should be bad one. Okay, so how to do? We can copy. So the bad chars. Okay, maybe not in this one. Why error? Missing. And then we can construct the payload. For example, the offset 4 bytes of EIP and bad characters. Then we can send we need to encode. Okay, very simple. So now we can run this, really run this binary. Exploit. So this should be exploit 2. Or not here. Python exploit 2. Run it. And then we can run. And then we can use the command, the X, to display the characters, 100 characters after this ESP, okay, in bytes. So we can copy. Okay, as you can see, 1, 2, 3, 4, 5, 6, 7, 8. So all the way to the final, and you can run this again. Of course, you can add, for example, you can add to 200. So I think in this case, no, we cannot. We didn't find any bad characters, which is a good thing, which make things to be easier or simpler. Okay, so now we can go to the PyCharm to, of course, also, sorry, we need to generate the shell code. Okay, so now we can use MS Vellum. And although we didn't find the other bad character, but this one we also this always would be the bad characters. This means the space, because space will affect the execution. And if we want to test on the local address, local machine first, and we can press enter. So the format is the Python, We can press enter. In the meantime, we can rerun the binary. As you can see, this shellcode has been created. So now we can go to here. So we can paste in here. Then we can generate the payload. Because here is byte, so payload would be 41, which means capital A, and then followed by the, the address of the jump ESP. Okay, so this should be this one. And we need to reverse this address. X 9D. We must be very careful. 04 X 08. Okay, and then of course we also need, before the actual shellcode, we need to add some non-operation. X90, for example, 32 bytes, and then buff. Then we can send the payload. We do not need to encode. We need to remove, save, and we need to set up the listener on the Kali Linux. And the binary has been executed. So now we can run this Python script again. As you can see, we got the collection, which means that our exploitation is successful on the local machine, on the Kali Linux. So next we need to make a modification. Because we want to exploit the target, and so the payload would be different. Let's run it, and we can copy and replace this part. And also we need to change the target IP address from the local machine to the target. So the target should be 120. We do not need to change anything else. So now we can, of course, also we need to set up the listener, and then we can run it again. Hopefully we can get the collection from the target. Yeah, it works. So we can check the Python. Python 2 is not there. Python 3 is not there. We can check the ID. So maybe we are inside the container. And so to confirm, we can run IP. From the IP address, we can deduce that we indeed is container or inside the container. And we can the Harry. Oh, we can get the creds. Actually, I think this should be the credential for this user, Harry. So I think we can quit from GDB because we have already made successful buffer overflow attack on the target. And then we can, we can use SSH, Harry. Yes. And the password. So the password is this one. However, it doesn't work. Do you remember that this machine has two open port number, both which both are running SSH service. So we can connect to the another port number, paste the, as you can see, it works. And so now, of course, we need to make privilege escalation. For example, we can check whether we can run all commands without supplying the password of a root user. So we can run the bin bash. However, bash is not there. So how about the shell? It works. So now we can do some local immersion because we have already become the root user on this. Although we are now still inside the container, we can cut out the node. Here, hello admin, we have found that someone is trying to log in to our FTP server by mistake. You are requested to analyze the traffic and figure out the user. So I think from this message serves the hints to, for the further exploitation, right? So maybe we can, of course, this is the first flag. I do not want to cut it out. If you want, you can do it by yourself. So I think next we need to analyze the traffic. And the most popular tool to analyze the traffic would be Wireshark. However, we are in the command line. So another alternative is TCP dump. TCP dump is there. So then we can use TCP dump to capture the traffic. And we can use TCP dump. We can use I option to specify the interface. And then port number, we are just interested in 21. 21, as you know, is running FTP service. So we just follow the instruction because someone is trying to log into our FTP server by mistake. And we are required to analyze the traffic and figure out the user. So we need to wait a bit of time to capture the traffic and to see whether we can find, as you can see over here, the different packets have been captured by TCP dump. And even here we got some user name information. We can copy, and then we can also get the password. So next, I think we need to check whether, although this of course is used by the FTP service, however, it deserves our tests to see whether such credentials are used by the system or SSH as well. Okay, so we can copy and SSH followed by the username, and we can copy the password, paste in here. It does work. Next, of course, we can get the second flag if you want. I think this should be encoded by base 64 algorithm. If you want, you can use the command line to decode, which is very easy to do. So next, maybe I can use NumPy shell script to do the automatic enumeration. And maybe I can open up another tab. Of course, I've already got this shell script ready, this one. So next, we need to upload this file onto the target. To do this, we can set up the web server on the Kali Linux, and then we can use wget to upload. NumPys. And to run, we need to change mode. It's done, and we can scroll up to see whether we can find the DB. I think the DB password. Just only one normal user. Maybe this should be used by the root. Doesn't work. Authentication failure. So we can continue our scrolling. We got this one. So how about this one? What's that? We can get out this file. Nothing special, right? And we can continue. SUID binary information. Cron job information. Although the two exploits by the suggester module, but maybe it's very difficult to exploit. I'm not going to do with these two exploits. However, as you can see over here, this version is vulnerable. It's a bit old. And I've already closed down the maybe I can quit from here. I've already made a clone from GitHub, and this exploit has something to do with the sudo, the vulnerable sudo. And this one is what we want. We can copy and copy to the working directory, okay? And also we can, oh, not this one, sorry about that. Vim exploit. And if you want, you can take a look at the code of a Python code. Here is sudo pass. So I think this is we must be very careful. If you locate or to get the path of the sudo on the target, as you can see, the path is a bit different. It means that we need to modify this part. We can delete and paste here. And then we can write and quit. Next, we need to upload these local exploits to the target. So where? That should be here. We can navigate to temp directory. paste the file name. And we need to, maybe we just use Python. However, we got the error, usage, invalid mode. So maybe I need to exploit, remove. We need to vim exploit. So there's some error. Cut out the exploit. Or I modify the wrong file. Okay. So this one not correct. So we need to modify it again. So the path should be which one? And this one. You can paste in here. Let's write and quit. And then we need to upload this Python code again. Oh, not this one. We just copy from here. Now we can run it. It does work. And then we can retrieve the final flag. Okay, so that's pretty much it. I'd like to see you in the next one. Bye. Have a nice day.